All right, let's go ahead and solve homework exercise number 11 from section 11.2. From a segment of a radio show, a disc jockey can play 6 records. There are a total of 10 records to choose. Select from how many ways can the program for this segment be arranged. Again, arranged, I would interpret it as order matter. So whether it's first or second or played third or fourth, whatever, order matters. So it does count, so it's a permutation. So we're going to use a permutation. We've got a total of 10 records, right? So 10 goes on the left, and we're selecting 6. So the answer is 10p6. So again, we could go ahead and use pencil and paper, use our calculator. So the formula is the number on the left, 10 factorial, and then take 10 minus 6, a number on the right factorial, which will be 10 factorial over 4 factorial, which is 10 times 9 times 8 times 7 times 6 times 4 times 5. And then 4 factorials are both in the numerator and denominator. They cancel, so our answer is going to be 10 times 9 times 8 times 7 times 6 times 5. However, again, you can use your calculator. Again, you would go ahead and put in the number, the total number. You start out with that 10, and then you go over to Math key, and then go over to use your right arrow to highlight probability at the top of the screen. And then we're going to use the NPR formula because order matters. So highlight number 2, or just click number 2. And then how many you're selecting in this case is 6. So we've got it all in, total of 10. It's a permutation selecting 6. And the answer is 151,200. Okay. That's strange. Kind of went out. See if we can get back to it. 10 records, 6. So it's that same answer. All right. Let's see if we can get it back. So we just did a 10p6, 151,200. All right, very good. We got it right. Okay. A little bit of a malfunction there in MyMathLab. All right, let's look at number 12. In a race in which 7 automobiles are entered, there are no ties in how many ways can first 3 finishers come in. Again, first 3, first, second, and third is distinguishable, so order matters. Okay, so it's going to be a permutation. So permutation, we've got a total of 7, and we're looking at the first 3, so 7p3. So again, it would be 7 factorial over 7 minus 3 factorial. So it's 7 factorial divided by 4 factorial, which would be 7 times 6 times 5. And then the 4 factorials will cancel. So the answer is 7 times 6 times 5. Okay? Or you can do it on your calculator. Again, you put in the number, total number you're working with, which is 7, and then you go ahead and go over to Math. PRB, we're doing a permutation, and we're selecting 3, first 3 finishers, and there's the number of ways, 210. Okay, or the other way, 7 times 6 times 5, of course, gives you 210. All right, number 13. At a benefit concert, 11 bands have volunteered to perform, but there's only time for 8 of the bands to play. How many lineups? Again, lineups means how many different orders. So again, order does matter. Okay, order does matter, so it's a permutation. So capital P for permutations, we have a total of 11, and there's only room for 8, so we're going to select 8. So 11p8 is going to be 11 factorial over 11 minus 8 factorial, which is 11 factorial over 3 factorial. So this one, you're going to have to multiply more numbers. You're going to have to go all the way down to 11 times 10, 9, 8, 7, 6, 5, 4. And then the 3 factorials will cancel, so your answer is going to be 11 times 10 times 9 times 8 times 7, 6 times 6 times 5 times 4. A lot faster to use your calculator. So again, we have a total of 11, and we've got the math, and we've got over to PRB, and it's a permutation. All right, and we are selecting 8, and so our answer is 6,652,800 lineups. Okay, because order matters. It really gets large quickly, and we are selecting 8, so that's why the number is so large. So it does make sense when you think about it that way. Okay, number 14, how many ways can the letters of the word deeds be arranged? Now, this is a completely different formula. Okay, what happens now is there are some of the objects are the same. So there's 2 E's and 2 D's. So you wouldn't be able to distinguish if you switched around the D's. So you're going to have less permutations. Okay, so this formula is permutations of duplicate objects. The way the formula works is you take the total number of letters. You don't worry about the duplicates. 1, 2, 3, 4, 5 letters, and you factorialize it. So it's 5 factorial. You divide by the number that are identical for each of the different letters. So there are 2 D's. So you divide by not 2, but 2 factorial. Now it happens to be 2 factorial is 2 times 1, which is 2. But if there is 3 D's, 3 factorial is 3 times 2 times 1, which is 6. So it is different. So there's 2 D's. We're going to divide by 2 factorial. There's 2 E's. So we're going to divide by another 2 factorial, or multiply them together and divide through. So what you have now is the 5 factorial is 5 times 4 times 3 times 2 times 1. Each of these 2 factorial is 2 times 1 and 2 times 1, right? Now again, you can do the factorials on your calculator. These numbers aren't that large. You can probably do it quicker by hand in this case. 5 times 4 is 20, times 3 is 60, times 2 is 120. And then this is 2. 2 times 1 is 2, another 2, 2 times, and then you take the 2 2's and you get 4. So finally 120 divided by 4 is 30. Again, the formula is you count the total number, that's the factorial in the numerator, and then you count the duplicates. 2 E's or 2 D's, 2 factorial, and then 2 D's, so divide by a 2 factorial again. Okay? So there's the formula, and what we get is, in this case, if we do all that, we got 30. Okay, very good. Now again, on your calculator, again, it's the numbers are so small, so it'll probably be faster, but remember the factorial is 5 math, and then over to probability, and then factorial is 4. So you got to use the factorials here is 120, and then again, divided by 2 factorial is what? Is a 2 for the 2 D's, and then you could divide by the 2 factorial for the 2 E's. You can do it one at a time, and there's your answer of 30. Okay, very good. All right, we're going to stop this session here. This is your math teacher, Dr. Suarez. If you have any questions or need more help, send me an email using the inbox through the Canvas course at the FGCU portal. Again, I hope you found this video helpful. Thank you for listening to it.